Hello, mic test, check. Am I audible? Is the screen visible? If I can have just a quick confirmation of that, then we can quickly start the session. Excellent. Okay then. So very good evening and welcome to everybody who is there online watching this session. I'm Satyanarayan and I'm one of the founding directors and the academic head at IQ Ideas. And I coach students for various undergraduate entrance examinations, primarily law entrance examinations like the CLAT and management entrance examinations like the IPMAT. So today's session, I'm going to take you through some brilliant, fantastic questions from the previous past year question papers of the IPMAT conducted by IIM Indore. I'll be showing you a few tricks of how these things can be done. These are some of the common type of questions which I've observed over the past few years. And let's hope for the best, see how it goes. Those who are writing the IPMAT Indore paper will be doing so on the afternoon of the 4th of May, that is the Monday. So you have got under 48 hours, 40 odd hours you have got, right? And excluding the sleep, you have got some hours. And it's a good paper. So if I were to just describe the paper, it's 3 sections, 2 of mathematics, 1 of verbal ability. You have the mathematics section of short answer questions where there are no choices given, where you have to type in the answer, but there is no negative marking for that. In case of multiple choice questions, of course, you have +4 for a correct answer, but -1 if you get it wrong in the maths multiple choice question format section. And then you have the verbal ability section, which is multiple choice, again +4 for a right answer and -1 for an incorrect answer. So 3 sections, 40 minutes each, and you are not allowed to switch between the sections. So you got an entire 40-minute for one section. Once the time is up, you can go with the next section 40 minutes, and you have to go in the order that they will be presenting it to you. So you can't save time in one section, allot it to the other. You can't select the order of sections, although within the section you are free to answer the questions that you want. And then if you are aiming for either IIM Indore or Nirma University Management Institute through the IPMAT, then there will be sectional cutoffs. And a lot of students are actually worried, or rather I would say curious to know what would be the cutoff this year. And very honestly speaking, cutoffs are not predetermined, right? It depends on how the paper is perceived by the students. Once the paper is given, then based on the number of students, based on how they have answered the questions, based on the scores, then some cutoffs are set, of course different for different categories of students. And you need to get a minimum score in each of the 3 sections to qualify for the next round, which would obviously be your call for the interview. And then based on your total performance in the writtens and in the interview section, then the final list is out, and then you get selected into the institute of your choice. So it could be IIM Indore, it could be IIM Ranchi, which I believe also takes the same exam score. It could be Nirma University here in Ahmedabad, and a handful of other universities which take the IPMAT. So before I start this session and the questions, if you have any queries or any doubts, I'll be happy to handle them. You can post them in the chat column. But because I'll be focusing a lot on the question, I'll periodically try to keep an eye on the screen and if there are any questions, there may be a lag between when you post it and when I notice it and I'm able to answer it. So I do crave your forgiveness for that, beg your pardon for that. But the main aim for this particular session is to show you how questions in the IPMAT by Indore are not actually very tough. What are the small hidden tricks and tips that you have to be aware about, what care you have to take for certain questions, so on and so forth, right? So kuch prep nahi hua hai, don't worry about that. If your fundamentals of mathematics are pretty clear and if you're decent in English, then there are a lot of different types of questions which can be solved just by having some basic fun day in mind. So hopefully the set of questions that I solved today will at least give you some fun day that you can try in the examination. And in the last moment, there is absolutely no point in panicking. And this is what I tell my students: don't try to cram new concepts in the last 24 to 48 hours before the examination. Focus on what you know, go through the past year question papers. You will see a lot of different questions which are easily solvable there, right? There are brilliant videos available on the internet from various sources which have actually solved these questions. So if at all you want to do something in the last couple of days, I would just very strongly suggest you take a look at the past year question papers, right? Don't panic about your preparation. If you're prepared, you're prepared. If you're not prepared, well, nothing can be done about it. So absolutely no point in worrying, right? You just give it your best shot and take it ahead from there. Okay. So let's take a look at the questions, and with each question also I'll try to give you some strategy of how to think for that question, what all you can do. So these questions which I solve will may in some way or the other help you understand things. So let's not without further ado, let's take a look at the questions. So here's the very first question. Seems something based out of geometry and mensuration. And it says a ball of diameter 4 centimeter is kept on top of a hollow cylinder standing vertically. Height of the cylinder 3 centimeter, volume 9 pi centimeter cube, vertical distance in centimeter of the topmost point of the ball from the base of the cylinder. Okay, seems like a simple question. So as a student, what would most of us think? Okay, there is a cylinder. So let's take the cylinder which is there. Okay, it is given that the height of the cylinder is 3 centimeter. Okay, height of the cylinder is 3 centimeter, volume is 9 pi, volume of the cylinder is 9 pi, and there is a 4 centimeter diameter ball on top. Okay, so something like this on top. So if the diameter is 4 centimeter, then what is the distance of the topmost point of the ball from the base? Topmost point of the base, oh, so easy, 4 plus 3, 7. Many of students would actually think this question is as simple as that. Put 7 as the answer, and because it's a short answer question, there are no options. You would think, okay, in short answer questions, I will get an integral number. Okay, easy, 7, type and move. So although you won't lose any marks on this, you're not going to get any marks for this either. Why? Because this is IIM, right? This is IIM Indore. Look at the question very carefully and you'll understand where the thing in the question is. First of all, why is the volume of the cylinder given as 9 pi? Because if your answer was 7, then that volume had no role to play in it. Okay, sometimes they might give you some additional information which is useless. But then, is the question really that simple? Well, take a look at this particular thing. It says that it is a hollow cylinder. And when the cylinder is hollow, it makes a difference to how actually the entire contraption is placed, how the ball is going to sit on top of the cylinder. So first, let's focus on volume of the cylinder. Volume of the cylinder, is area of the base, which is a circle, so pi r square multiplied by height, which is given as 9 pi units. So pi into r square, height I know is equal to, the height of the cylinder is 3 centimeters, into 3 is 9 into pi. So pi and pi gets cancelled, 3 3s are 9. So I get r square is equal to 3, or I get r is equal to root of 3, right? So for the radius of the cylinder is root 3 centimeters, that is 1.7 centimeters something, but that is immaterial. Now comes the real trick in the question. It says that it is a hollow cylinder. So if it is a hollow cylinder with the height as given as 3 centimeters, and we have just discovered the radius is root 3, which means 1.7 something. So the diameter is double of that, roughly 3.4 something. So the entire thing is 3.4, and the diameter of the ball which is kept on top is 4. So the ball is slightly wider than the cylinder. And remember, the cylinder is hollow. So then if I take a look at it, the ball is going to sit something like this on the cylinder, which means the ball is not exactly resting totally on the cylinder. It is somewhat sunk inside the cylinder, which means I have to account for this particular distance. How much of the ball is inside the cylinder makes an absolute difference to the question. So let us make a better diagram of this. Let us say this is the top of this is the cylinder, and I have got the entire ball sitting somewhat like this, right? And I know the radius of this particular thing, the radius is given as 4 centimeters the diameter, so 2 centimeters the radius, which means this particular thing will also be 2 centimeters. From the center to the tip, this is the radius. And I know that the radius of the cylinder is √3. So now comes the very interesting thing. If you take a look at this shape, it's a right-angled triangle. And if that is a right-angled triangle, let us assume the height of this triangle is x. So using Pythagoras' theorem, x square plus √3 square, which is 3 is 2 square is 4, or I get x square is 4 minus 3, 1, or I get x is equal to 1. So I know the height of this particular thing is 1, and if I know that the entire radius is 2, then the portion which has sunk inside is 1, right? So in reality, my height of the entire cylinder is 3 centimeters, and the part which is sitting outside is this portion x1 plus the remaining radius, which is 2. So 2 plus 1 plus 3, the distance of the top of the ball from the base of the cylinder is actually just 6 centimeters, not 7. The trick in the question was understanding that the ball is not sitting totally on top of the cylinder. Some portion of the ball has actually sunk in. So you have to account for that thing. But using basic funda of Pythagoras' theorem, we were able to very clearly identify that. So in this particular question, we needed to be careful in creating the diagram. So for whenever you get questions of geometry, whenever you get questions of mensuration, area, volume and all that, be very sure that you have to create the diagram, draw it on paper, visualize it, take care of all the different points that are given, and you will be quickly able to identify that what is the catch in this particular question. So definitely an easy one, nothing to worry about, but slightly tricky, right? So the answer to this particular question was 6. Okay. Let's move on to the next question. Now, functions is a very, very popular type of question which comes in IIM Indore. They're very popular for giving questions on functions where they would define f of some variable is equal to something, and then you have to identify things. So this question is actually one of just writing out steps. It says f of x plus 2 is f of x plus f of x plus 1. So let's first understand the function. It says f of x plus 2 is equal to f of x plus f of x plus 1, right? What does that mean? If I substitute the value of x is equal to 1, then f of 1 plus 2, that is f of 3, is equal to f of 1 plus f of 2. If I substitute the value of x is equal to 2, then I get f of 4 is equal to f of 2 plus f of 3. I mean, just looking at it also, I can say that for any variable x, the function is defined as the sum of the two previous consecutive numbers, right? And once this insight is clear in my mind, let's take a look at what the question asks. It says, I know the value of f of 11 is defined as 91. The value of f of 15 is defined as 617. and I need to find out what is the value of f of 10, right? So we start with f of 15. So I can define f of 15 as the sum of the two previous numbers, that is f of 13 plus f of 14, right? If I swap the numbers for comfort, let us say this is equal to f of 15. Now I don't know the value of f of 13, but again I can define the value of f of 13 as f of 11 plus f of 12. For f of 14, I can define it as f of 12 plus f of 13, and that is equal to f of 15, for which I know the number 617. And now you will understand it's just a matter of iterating again and again. So f of 11, I already know the value, right? For the time being, let's keep it as f of 11 plus f of 12 can be written as f of 10 plus f of 11. So we are good here. We have got all terms f of 11 and f of 10, the two things which we require. In the next part, f of 12 plus f of 13, f of 12 can be again written as f of 10 plus f of 11. Again, in terms of 10 and 11, I've got the answer. And the last thing, f of 13, is f of 11 plus f of 12. So f of 11, I will keep it as it is. F of 12, I will again write it as f of 10 plus f of 11. And that entire thing is equal to 617. Brilliant. Now I've got everything in terms of f of 11, f of 15 and f of 10. So if I assume f of 10 is equal to x, right? So let's see how many f of 11s we have. So we have got one f of 11, twice, thrice, 4 and 5. So 5 times f of 11 plus f of 10 once, twice, thrice. And I've assumed that to be x, plus 3 times x is equal to 617. A very simple linear equation. Why? Because I know the value of f of 11 is 91. So I get 3x is 617 minus 5 times 91. 5 times 91 is 455. So 617 minus 4 by 5. So 617 minus 455, I get 2, I get 162. So if I get 3x is 162, I get x is 162 divided by 3, that is equal to 54. So x was f of 10, I get the value of f of 10 equals 54. Looks like a long problem, looks like something which is complicated, but technically it is not. You just have to reiterate the steps again and again. Don't make a silly mistake in dismantling 15 into 14, 13, 14 into 12 and 13, 13 into 11 and 12, 12 into 10 and 11, and till you get the numbers that you want. You need f of 10, you need f of 11, you need f of 15 in the equation. And once you split it like that, absolutely easy. So many editions of the IPMAT have actually had questions of functions, and believe me, although the numbers seem huge, doing it step by step and identifying the pattern is the easiest way to crack this sort of a question. So I hope you get some simple sum like this of functions which you are able to quickly solve, and the answer, as you can see right here, is 54. Okay, now let's take a look at another question. So here we have a definition given that let T1, T2 be real numbers such that T1 plus T2 plus up to Tn is 2n square plus 9n plus 13 for every positive integer n is greater than or equal to 2. And if T of k is 103, then k equals what? Okay, looks complicated, but don't worry about it. First, let's just understand what they're saying. They're saying T1, T2, all that blah 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 is a set of numbers. Okay, so it is given that the summation of the n numbers, so when I add numbers, let us say 1 plus 2 plus 3, I call it the sum of these numbers. So the sum of n numbers, which is equal to T1 plus T2 up to Tn, is defined as 2n square plus 9n plus 13. Now I need to find out an equation which tells me how is the nth term depicted in terms of n. What is the formula for Tn? Right, Tn is the last term. So if I can subtract the terms from n to n minus 1 from this, whatever is left over is my nth term. So I need to subtract the summation of the first n minus 1 terms. So basically I need the value of s of n minus 1. I've got a formula for s of n. So here 2 into n minus 1 square plus 9 into n minus 1 plus 13. If I put it, then the summation of the first n minus terms will come in terms of n. So let's first expand this. So this becomes 2 into n square minus 2n plus 1. Remember your identities, n minus 1, a minus b the whole square is a square minus 2ab plus b square. This becomes plus 9n minus 9 plus 13. Brilliant. Now let's again open this and simplify it. So this becomes 2n square minus 4n plus 2 plus 9n minus 9 plus 13. Great. So this can be written as 2n square minus 4n plus 9n is plus 5n plus 2 minus 9 plus 13, 15 minus 9 plus 6, right? So let's quickly check whether we have done this correctly. To n minus 1 the whole square is n square minus 2n plus 1 twice. Then we have n minus 1 into 9 minus 13. So 2n square minus 4n plus 2 plus 9n minus 9 plus 13. So 2n square plus 5n plus 15 minus 9, 6. Okay. So I can find out the nth term as Sn minus Sn minus 1. So that is 2n square plus 9n plus 13 minus this. So minus 2n square minus 5n minus 6. So 2n square and 2n square gets cancelled. 9n minus is 4n. 13 minus 6 is equal to 7. So the nth term is depicted as 4n plus 7. Brilliant. So now T of k is 103, right? So 103 is equal to 4k plus 7, which means 4k is 103 minus 7, which is 96, which implies k is 96 divided by 4. 4 2s are and 4s are. I get the value of k is 24. That's it. Great question which tests you on summation formula, but you don't need a summation formula, it is given to you. It tests whether you can apply the concept that the nth term that you require can be achieved by subtracting the sum of first n minus terms from the sum of the n terms, right? And because you know the formula for summation of n terms, you can use it to derive the formula for summation of n minus terms. And once you subtract one from the other, you get the formula for the nth term. And then it becomes a question of solving a simple linear equation. So this is an absolutely easy question, right? The third question I believe which we did has the value 24 here. Great. I hope you are following me so far. All of these are actual past year questions of the IPMAT, and although they seem a bit long or difficult, believe me, when you're doing it without explaining it to somebody, when you're doing it on paper, they are absolutely easy to solve. You just have to be meticulous in every step that you follow. All right, let's move on to the next question. Now this was a question which was brilliant. It takes a little bit of finesse, a little bit of guesswork, smart guesswork, but absolutely doable. The question simply says, what is the smallest integer n such that n cube minus 11n square plus 32n minus 28 is greater than 0? So if I find some value of n for which this entire thing is 0, right, then any integral value greater than that value for which it is 0 is my answer. So how do I do it? How do I factorize this number and get? I can start randomly plugging in numbers. Intelligently, it says if I take small numbers 1, 2, 3, 4, then 11n square is negative and 28 is negative. So I need some really large value of n which is going to make the entire thing positive. So I can 11n square. So if I take values like 11, I can assume n is 11, I can assume n is 10, and then keep on going down till I get a number where it turns negative, right? That is one way of doing it. The other way is, let's start with basics, because IPM, IIMs, they don't really expect you to plug in random large values. Always start with the basic numbers, 0, 1, -1, and so on. So if I take the value as 0, absolutely it is not going to be greater than 0, because it becomes -28. If I take the value of n equal to 1, then this becomes 1 minus 11 plus 32 minus 28. So that is 33 minus 28, definitely not greater than 0. So n is 1 also does not work. If I take the value of n is equal to 2, then this becomes 8 minus 44 plus 64 minus 28. So 8 plus 64 is 72, 44 plus 28 is also 72. Oh, brilliant. So for the value n is equal to 2, it becomes 0, right? But will it work for 3, 4? I don't know. So I know that n minus 2 is a factor of this entire polynomial, right? This thing is definitely divisible by n minus 2. So let's try to identify what can be the other roots, what can be the other factors for this. So if I've got n cube minus 11n square plus 32n minus 28, let's try to factorize this by n minus 2. And I hope you know how to factorize the polynomials. If not, pay close attention here. So n and n, I need a square, I need a cube. So first I will multiply by n square. So n minus 2 into n square is n cube minus 2n square. I subtract this, changing the sign. So n cube subtracted minus 11 plus 2 is minus n square. I take down the next term, which is plus 32n. Now n, I can multiply by minus 9n, minus 9n. So n into minus 9n, minus 9n square, minus 2 into minus 9n plus 18n. I change the signs. This term gets cancelled. 32 minus 18n. So 32 minus 20, 12. This will be 14n. And I take down the final term minus 28. N and 14. So plus 14. So n into plus 14n minus 2 into this minus 28. Brilliant. Change the signs, subtract, I end up with 0. So I get my factors. N minus 2 is a factor, and the other factor is n square minus 9n plus 14. And I can split this as n square minus 2n minus 7n plus 14, because minus 2 plus minus 7 is minus 9, minus 2 into minus 7 is 14. So this I can take it as n into n minus 2 minus 7 into n minus 2. Taking n minus 2 common, I get n minus 7 as the other factor. So the entire thing is practically n minus 2 the whole square into n minus 7. If I take the value as 2 or 7, they are going to be 0. If I take the value between 2 and 7, right, the value greater than 2 but less than 7, then let's say I take 3. So n minus 2 square, 3 minus 2 square is positive, but 3 minus 7, one negative term, the value still becomes negative. So I have to take the values of n greater than 7, then n minus 7, if I take 8, then 8 minus 1 positive, 8 minus 2 positive, positive into positive, positive. So for every integral value of n which is greater than 7, the entire term will be greater than 0. So the first integral value which is just over 7 and which gives a positive thing is 8. So in this query, in this particular question, the value of n, which will definitely give me something for this entire polynomial as a value greater than 0, has to be 8, right? So I hope you got this particular question, right? A very, very interesting question where either you could have guessed numbers at random. If you had started with 10, 9, at 8 you would have got a positive value, at 7 you would have got a negative value, you would have got 8. But then you have to play with 10 square, 10 cube, 10 square, 9 cube, 9 square and all that. Other than that, if you had quickly identified n minus 2 is a factor, then you could have factorized the polynomial and then easily you could have got the answer to this one. So this was definitely one of the brilliant questions where the answer definitely in this case was 8. I hope you are following me so far. Quick look at things. Okay. Chalo, moving on then. Okay. This is a question which I have seen being asked so many times in the examination, where you are given a linear equation with modulus and then you are told what is the area of the graph. And such an easy question to solve. Believe me, one of the easiest question to solve, and I have seen this type of question being asked so many times in the past year papers. Now, before we proceed, let's first understand a simple funda. What is meant by modulus? So if I say the modulus value of x is 2, then it means x can be 2 or x can be minus 2. So the modulus value of a positive number is the number itself. The modulus value of 0, 0 has no sign, is 0. But the modulus value of a negative number is the positive value of the number. Right? So when I say modulus of x is 2, it means x is either plus 2 or minus 2. So keeping that in mind, it says the modulus of x plus the modulus of y is equal to 2. So to plot this graph, I need values of x and y which will satisfy it. First and most important step, first assume the value of x is 0. The moment you get the value of x is 0, I get the equation modulus of y is 2, which means y is equal to plus or minus 2. So I get a coordinate 0, 2 and I get a coordinate 0, minus 2, right? So if I want to plot this on a graph, let us say I have a graph like this. So value of x is 0, value of y is 2. So 1 is this point, 0 and minus 2, I get another point. Now the second step, I will assume y is equal to 0, which means modulus of x is 2, which means x is either plus or minus 2. So now I get the coordinates 2, 0 and minus 2, 0. So now 2, 0 is this point, minus 2, 0 is this point. I've got 4 points. Let's connect all of them. So I can connect these two straight line, these two straight line, these two straight line, these two straight line. Why straight line? Why not a curve? Well, the power of the variables is 1. Linear equations, straight lines. Quadratic equations, power 2, you will get curves. But here it's a linear equation, so straight lines. And beautiful. Now, if you take a close look at it, we'll be quickly able to identify that it is nothing but 4 right angle triangles, right? If you take a look at this structure, this is a right angle triangle where the base is 2 units and the height is also 2 units. The base is 2 units because from 0 it goes till 2. And the height is also 2 units because it goes from 0 to 2. And all of them are identical. So the area of 4 triangles is 4 times half into base into height. Each of the triangle is an identical triangle. Each of them has a base 2 and a height 2. So 4 times half base into height. Simplify this, you will get the overall area that you need is simply 8 square units. So where you have a question of modulus or area under the curve or area of the line, area of the shape formed on the graph, and it's a linear equation and you have 2 variables x and y. The obvious thing to do is first let one of the variables x be 0. What are the possible values of y? You get a set of coordinates. Then assume the other variable, in this case y is equal to 0. You get a set of values for x, you get a set of coordinates. Plot all of these on the graph. And once you have plotted it, it will generally turn out to be some sort of a triangle or a quadrilateral. And then using basic principles of geometry, basic principles of area, you will be able to calculate it. So although it seems complicated, believe me, multiple times I have seen questions based on this funda, and each time single way of solving it, just assume x is 0, get values of y, let y is 0, get values of x, get the coordinates, plot it, calculate it, done. One of the easiest questions, easiest type of questions that I have seen in IPM. Alright, so in this case, third option 8, definitely my answer. And I should have been 4 or 8 because straight line, so I cannot have pi. The value pi can only come if we are talking about a shape which has a curve in it. And linear equations, straight lines, so the pi options were obviously not my answer. A and D has to be eliminated, had to be either 4 or 8. All right. This is one of my favorite type of questions, logarithms, right? When I'm teaching my kids, my students, they say, log ka question aa gaya to sir ki aankhein aise hi chamakti hai. But believe me, I have seen so many questions of log in IPM, one of the favorite topics, and absolutely easy. And why? Because there are just a handful of concepts of log that you need to keep in mind. And believe me, every single question of log uses just these basic concepts. So before we take a look at this question, let's quickly revise our fundamentals for log. So what does log mean? If I say a raised to the power b is equal to c, then logarithmically I will write it as log of c to the base a is equal to b. A raised to b is equal to c. This is how I remember it. So if I say log of 8 to the base 2 is equal to 3, technically what I mean is 2 cube is equal to 8, right? So log is just another way of representing exponents, powers. So this is the basic concept of what a log representation is. Now we have some basic funda. If I say log of x and I put nothing in the base, then the default base is always 10. So when no base is mentioned, by default the base is always 10. If I say log of a plus log of b, and I'm assuming the base is same in this case, then log of a plus log of b can be written as log of a into b. Similarly, log of a minus log of b can be written as log of a divided by b. For plus, multiplication, so negative, addition. Then log of a raised to the power b, you can always take the power outside and write it as b times log of a. So log of a to the power b, you can take the power outside, write it as b times log of a. Log of a to the base b, and remember, this is the most important transformation used in maximum amount of log problems of IPM. Log of a to the base b, this is called change of base. So I can write it as log of a to any random base c divided by log of b to random base c, right? I could use any other base. I could say this is log of a to the base 53 upon log of b to the base 53. The base does not matter as long as it is same for both. So it's very convenient. So if log of a to the base b is given, I can always write it as log of a upon log of b. Base has to be same, does not matter what the base is. So very convenient when some random base is given. You can split it. And log of a to the base b can be written as 1 upon log of b to the base a, right? In fact, this thing uses the concept of splitting, changing the base. Why is log of a to the base b the same as 1 upon log b to the base a? Think about it, split it and try it. You will, if you work this out once, you will understand why log of a to the base b can be written as 1 of log of b to the base a. Now, these are most of the concepts that you need to know. If you understand these formulae, believe me, understanding most of the questions of log is absolutely easy. So let's take a look at it. It is given that log of x to the base 3 is a. So I can write x is 3 to the power a. Brilliant. Log of y to the base 12 is also a. So I can write y is equal to 12 to the power a. So I got the value of x, I got the value of y. Okay. It says x and y are positive numbers to be kept in mind. Okay. Now it says g is the geometric mean of x and y. Now here is another concept that you must definitely keep in mind. The arithmetic mean of two numbers a and b is given as a plus b by 2, average. The geometric mean of two numbers a and b is given as the square root of their product. So if you have to find the arithmetic mean, add, divide by 2. If you have to find the geometric mean of the number, you take the square root of the product, right? So let's use this funda. It says the geometric mean, G is the geometric mean of x and y. So I get G is equal to root of x and y. And I have to find the value of log of G to the base 6, okay? So log of G to the base 6 can be written as log of root xy to the base 6. Now, I can write the square root of any number, let us say 3, is nothing but 3 to the power 1 by 2. Square root of, let us say, p is nothing but p raised to 1 by 2. So the square root, I can write it as log of xy raised to 1 by 2 to the base 6. Great. And remember, log of something's ka power, the power can be taken outside. So I can write it as half of log of xy to the base 6. Now, life is so simple. I know the value of x. So I keep it as half log of x is 3 to the power a. So this is 3 to the power a multiplied by y is 12 to the power a to the base 6. Very interesting. What can be done? Since both of them have the same power, I can write it as half of log of 3 multiplied by 12 to the common power a to the base 6. Now, power again I can take outside. So I can write it as a upon 2 into log of 3 12s are 36 to the base 6, which I can write as a upon 2, and 36 is nothing but log of 6 square to the base 6. Again I can take the power outside. So 2 into a upon 2 into log of 6 to the base 6. And funda, 6 raised to what number is equal to 6? 1. So this entire thing becomes 1. 2 and 2 gets cancelled. We are left with nothing but a. So the final answer that we are looking for is simply a, fourth option, D. Correct? So absolutely great question of log. Because I had to explain a lot of concepts, so we went step by step. It took us some time to reach there. But believe me, in the examination, if you are very, very clear with your fundamentals of log, then such a amazing looking question can actually be solved very, very easily, right? Don't get frightened. Two concepts were tested here. One, of course, all your fundamentals of log, but it also tested whether you understand what is meant by the geometric mean of a number. So the geometric mean of a number is the square root of their product. That's the only thing that you need to keep in mind. All right? Right. So my answer A, option D, absolutely right. Okay. Let's move ahead. Oh, yet another log question. So let us see whether this is also easily solvable using just the basic funda that we had seen. So it says log of root of 5 to the base 0.008 plus log of 81 to the base root 3 minus 7. I have to evaluate this. Now, whenever the bases are different, splitting of bases is what I'm going to do. So I'm going to write this as log of root 5 divided by log of 0.008 plus log of 81 divided by log of root 3 minus 7 can be kept as it is. Now, we had seen even in the previous example, when I had a square root, power I could take as 1 by 2. So I can write it as 1 upon 2 into log 5 upon log of 0.008. I don't like numbers in point. So as a fraction, can I write it as log of 8 upon 1000? Absolutely. Now 81 and 3. 81 is also power of 3 actually. So I can write it as log of 3 to the power 4 divided by log of 3 to the power half minus 7. Now, what do we do? Log 5. Now, here's a simple trick that you should remember, that log of 5 is actually log of 10 divided by 2, which can be written as log of 10 minus log of 2. And when the base is always 10, log 10 to the base 10 is 1 minus log of 2. So I can always write log of 5 as 1 minus log of 2. It's an important derivation to keep in mind. So let's put it as 1 upon 2. Instead of log 5, I write it as 1 minus log of 2 divided by. Now let's take a look at this. Log of 8 upon 100 can be written as log of 2 upon 8 upon 1000 can be written as log of 2 by 10 cube, which can be written as log 3 times log of 1 by 5, which can be written as 3 times log of 1 minus log of 5, right? Because log of a by b is log a minus log b. So this can be written as 3 into log of, log of 2 by 5, log of 2 minus log of 5. Sorry, 2 by 10, I was right. So I can write it as log of 2 minus log of 10, which is 3 times log of 2 minus 1. Okay. So this I can write as 3 times log of 2 minus 1. So as you can see, 1 minus log 2 minus 1, negative. So this becomes negative 1 by 6. Now let's take the second term down. 4 times log of 3 upon half time log of 3. Log of 3 gets cancelled. 4 divided by half plus 8. And then don't forget the last term, minus 7. 8 minus 7, 1. 1 minus 1 upon 6. I come to 5 by 6. Right? A little bit of goof up in these steps, but nevertheless we reached the answer. And 5 by 6, yes, I have an option C. So in this case, log of 5 by 6 can be my answer. 5 by 6 is my answer, not log of. 5 by 6 is my absolute answer in this case. I hope everybody got this one, right? If you are still following this, can I just have a quick confirmation or a thumbs up or something in the chat so that I know people are following? All right. Let's move on then. So this is option C, 5 by 6. Okay. Now, 9 raised to 2x minus 1 minus 81 raised to x minus 1 is 1944. Then what is the value of x? Seems very complicated. But something which immediately comes to my mind is both 9 and 81 are actually related. 81 is nothing but 9 square. So instead of keeping it as 81, can I do something like this? Let's keep it as 9 raised to 2x minus 1 minus 9 square raised to x minus 1 is 1944. Okay. So this I can write as 9 raised to 2x minus 1 can actually be written as 9 raised to 2x upon 9, because 2x and this is 9 power 1, right? And this I can write as 9 raised to 2x minus 2. So 9 raised to 2x minus 2. So that becomes 9 square is 1944. Now I can write 9 raised to 2x upon 9. I can actually take it as common. 9 raised to 2x upon 9 is common in both the terms. So this becomes 1 minus 1 upon 9 is equal to 1944. Excellent. So 9 raised to 2x upon 9, 1 minus 1 upon 9 is 8 upon 9 is equal to 1944. So I can write 9 to the power 2x is 1944 into 9 upon 8. If I divide 1944 by 8, is it divisible? Should be. Let's check. So 8 ones are, 8 twos are 16, 8 fours are 32, 8 threes are 24. Brilliant. So I get 9 to the power 2x is equal to 243 is nothing but 3 to the power 5 into 3 square into 3 square. Let's convert this also into 3. So 3 square raised to 2x, 3 raised to 4x is 3 raised to 9. So comparing the powers, I get 4x is equal to 9 or x is equal to 9 by 4. And do I have 9 by 4? Yes, option B, I have got the power, the value as 9 by 4. So in this case, simplifying everything to some common number, some common term could get us there, right? 1944 is actually not divisible by, it is actually divisible by 3. It is also divisible by 9 actually, but dividing it is not going to help us much. So first we simplify it like this, we can absolutely get the answer here, right? So seemingly tricky question, but you just had to mechanically solve the exponents and 100% you will get the answer to this. Let us see if option B is my answer. Yes, option B is my answer. Great. Let's move ahead. Now this is one of those arithmetic type questions which are there as sitters in the paper for students who are comfortable with basic arithmetic. So you will have questions of simple and compound interest, profit, loss and discount, percentages, averages, ratios, and so on and so forth. So what I'm going to do is I'm actually going to use something called allegation method here. Now, so before we take on the problems head on, let's first understand what is meant by allegation. Okay. So let us say I have got two quantities A and B. If the value of A is 30 and the value of B is 40, right, then the average value of A and B is simply 30 plus 40 divided by 2, which is equal to 35, which sits exactly between A and B. But supposing I have got 2 times A and 3 times B, right? Then 5 quantities, what will be the average? So 2 times A, so 2 into 30 plus 3 times 40, so 3 into 40, and the total number of quantities 2 plus 3 is 5. So 2 30s are 60 plus 4 3s are 120 divided by 5. So 180 divided by 5, I get my answer as 36. So when they're in the ratio of 2:3, the average is 36. If I'm given the individual quantities and the numbers, I can find the average. But allegation is the reverse engineering of this. If I know that A has 30, B has the value 40, and I know the average value is 36, then in what ratio have they been combined? So the easiest way to do this is write the two numbers and the average in between, and then you subtract them in cross. 30 and 36, the difference is 6. 36 and 40, the difference is 4. So if I simplify this, it's 4 and 6, 2 and 3, and that was absolutely the ratio which we had. So this is called the method of allegation, where if you have got the weighted average of two quantities, you can use this to find out the ratio of the two numbers. Let me take one more example. If I say that one of the quantities is 20, one of the quantities is 30, and my average value is 22, then in what ratio are they mixed? So the difference here is 2, the difference here is 8, simplifying it. The first quantity is 4, the second quantity is 1. And you can always, looking at the value, say which is going to be larger, right? The exact middle would have been 25, but 22 is more towards the smaller number. So the smaller number has to be in larger ratio. Absolutely. In the other problem we had seen 30, 40, middle value should have been 35, but it was 36, leaning towards this. So my ratio 2:3, the larger ratio was this. This is the basic concept of allegation. Now, how exactly does it help us solve questions of ratio proportion? Let's see that. Beg your pardon. So this says bottle 1 contains a mixture of milk and water in the ratio of 7:2. That means total units 9. We can take it as 7x, 2x and 9x, but for the time being I'm keeping it like this. and bottle 2 contains a mixture of milk and water in the ratio of 9:4, so 9 plus 4 is 13. And in what ratio or volume should the liquids be combined to get the mixture where milk and water is in the ratio of 3:1, total of 4, right? So here what I can do is I can create some sort of a linear equation and do blah 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 blah. But what about using alligation? We can. How? Let's focus on one of the components. Let us say milk, right? So the proportion of milk in the first one is 7 out of 9. The proportion of milk in the second is 9 out of 13. And the required average proportion is 3 out of 4, right? 7 out of 9 is milk, 9 out of 13 is milk. I require 3 out of 4 as milk. So if I just do this crisscross thingy, if I take 7 upon 9 minus 3 upon 4, if I take 9 upon 13 minus 3 upon 4, whatever numbers I get here will be the value of the ratio. But for fractions, so easiest thing, take a look at the denominators, 9, 4 and 13. So multiply the first by 4 and 13 because it already has 9. Multiply 9, it already has 13, so multiplied by 9 and 4. And 3 already has 4, so multiplied by the other two denominators. So 9 and 13, that's it. So once you get this, this and this, you can forget the denominators. And then difference, and you will get the answer. So at this point of time, all you are left with is the calculation of these numbers. And I've heard IPMAT may have a calculator. If that is the case, you are in heaven. Even if that is not, I don't think calculating these values should be of any difficulty, right? You should be absolutely able to calculate. So let's do that. 7 4s are 28, 28 into 13. So 280 plus thing becomes 364. 9 9s are 81, 81 4s are 320 plus, okay, 324. And 9 3s are 27. 27 into 13 is 351. So the difference here is 13. The difference here is 27. So my ratio is 27:13. Option B, 27:13 is the absolute answer that we are looking for. So alligation is a brilliant method of identifying the ratios of two numbers which are mixed in different, they are not 1:1. If they are mixed in a ratio, getting this ratio from the average value is easy. Second, if you have to subtract values which are in fractions, taking the LCM of the denominators, making all the denominators common, you can absolutely eliminate the denominators and then just work with the numerators, which will be integral values, right? So very, very easy type of question. Calculation intensive, but if you have a calculator on screen, absolutely easy. Even if you do not have a calculator on screen, multiplying these numbers won't take you more than 6 or 7 seconds per calculation. So option B has to be my answer in this case. Absolutely right. Great. Again, a very, very popular type of question which comes in exams. And this is a combination of, I would say, summation and progression or series. Let's understand this question. It says my first term is 1 upon 2 into 5. My second term is 1 upon 5 into 8. My third term is 1 upon 8 into 11, and so on and so forth. And I have to add all terms from 1 to 100, right? So whenever this thing comes up, believe me, it is a question of identifying what series it is. So let's focus on the denominators. So my first series, the first number of the denominator is 2, 5, 8 and so on. So this is an arithmetic series with 2 as my first term and common difference is 3. So the nth term of the series is given by a plus n minus 1 into d. Remember, for an arithmetic progression, the nth term, the first term a plus n minus 1 into d. Second term a plus 2 minus 1 into d. Third term a plus 3 minus 1 into d. So nth term in this case is 2 plus n minus 1 into 3. So 2 plus 3n minus 3 is equal to 3n minus 1. My first term is 3n minus 1. The second series is 5, 8, 11 and so on. So with 5, 8 and 11, my first term is 5. My common difference again is 3. So my nth term is a plus n minus 1 into 3. So 3n minus 3 plus 5 is 3n plus 2. Great. So now any term in this series can be written as 1 upon 3n minus 1 into 3n minus 2. You can try this. Put the value of n as 1. So this is 2 and this is plus 2, sorry. So, and 5. You put n is equal to 2, 5 and 8. You put n is equal to 3, 8 and 11, right? Now, here comes the interesting part. I need to convert it into an addition or a subtraction of two numbers where something upon the first term plus or minus something upon the second term, right? So I can write, if I write it as 3n plus 2 minus 3n minus 1. Take a look at it. 3n minus 3n gets cancelled, 2 minus minus 1. So this is 3. So I need 1 on top. This is 3. So I can write it as 1/3 of this upon 3n minus 1 into 3n plus 2. And this can be written as 1/3 of 1 upon 3n minus 1 minus 1 upon 3n plus 2. And this is exactly what we were waiting for. I got it as addition or subtraction. In this case, subtraction of two terms. So my first term is this 3n minus 1, which is 1 upon 2. So now if I want to write 100, if I want to write the summation, the addition, then it is 1/3 of my first term for n is equal to 1 is 1 upon 2 minus 1 upon 5 plus the second term 1 upon 5 minus 1 upon 8 plus third term 1 upon 8 minus 1 upon 11, so on and so forth, plus what will be my 100th term. So this is 3 into 100, 300 minus 1 upon 299 minus 100th term 1 upon 302. And now comes the brilliance. 2 does nothing, but this cancels out. This cancels out. So first term is left, the other terms will keep cancelling. So if the first term is left, last term will be left. Everything else will cancel out. So this just becomes 1 upon 3 into 1 upon 2 minus 1 upon 302. Now this is easy. 1 upon 3, 151 into 2, right? So this becomes 151 minus 1 upon 302, which is equal to 151 minus 1, 150 upon 3. So 50 upon 302, which can be simplified as 25 upon 151, and that's my first option. So this is one of those classic examples where you have to understand when the series is going, definitely you will be able to split it into, you can represent each term as 1 upon x plus 1 upon y or 1 upon x minus 1 upon y. So when you add all those terms, all the terms in middle will get cancelled out. The first and the last will be the last man standing. And then it will be a question of simply calculating the value of that fraction. But the trick is, how do I convert this into this, and from that I come to here? That is the beauty. But you can easily use the concept of arithmetic progression to get what is the equation of Tn, and then it's just a matter of trying, right? So looks complicated, but believe me, IPM has asked this type of question so many times in the exam that if you are able to get the hang of it, then you will absolutely be able to solve it in the examination also. So option A, the first one, has to be my answer. Yep, A is the answer. Great. Let's move on to another one. A long question, but if you get the way to do it, absolutely easy. So let's first understand what this question says. It says, given an equilateral triangle T1 with sides 24 centimeters. So equilateral triangle means each of the three sides are equal 24, 24 and 24. A second triangle T2 is found by joining the midpoint of the sides of T1. So midpoint, midpoint, midpoint. If I join, I get a triangle inside. Okay. Then a third triangle is formed by joining midpoints of T2. Okay. So let's take the midpoints of the inner triangle and join them. Then midpoint of the inner triangle, join them. So infinitely I can keep going like this. And this process of forming a triangle is continued. The sum of the areas of infinitely many. So whenever you see the word sum and infinite, remember there is a formula for an infinite geometric progression sum. This is definitely using that formula. So first things first, let us quickly work out the area of triangle T1. So for an equilateral triangle, root 3 by 4 x square is my formula for the area of the equilateral triangle where x is the side. So this basically becomes root 3 by 4 into 24 square. Brilliant. Whatever the value that is, we'll keep it as it is. Now, I have the second triangle. So if the first triangle is that, what is my second triangle area? If you take a look at it carefully, the inner triangle is the same as these three other triangles. So the area of the inner triangle will be 1/4 of the first triangle. So T2 will be 1/4 T1. Similarly, T3 will be 1/4 T2 and so on and so forth. So every inner triangle is 1/4 of the previous one. Great. So my first term is root 3 by 4 into 24 square, and my common ratio is 1/4. It becomes 1/4 every time I go ahead. And I know the sum of an infinite GP is nothing but a upon 1 minus r, provided r is less than 1. In this case, yes. So I get root 3 by 4 into 24 square upon 1 minus 1/4 is 3/4. So these two things get cancelled. I get 24 square upon root 3. 24 is 576 upon root 3. Unless we have missed out something. Have I missed out something? Let me quickly go through the calculations. Root 3 by 4 into 24 square. Upon 1 minus 1/4 is 3/4. 4 and 4 gets cancelled. 24 square upon root 3. What did I miss? No, okay, sorry. It's not division. Okay. So this is into root 3 and this is 3. So this becomes 3 1s are, 3 9s are, 3 2s are 192 root 3. Yep, we have the option. Yeah. I thought the answers were divided by. It is 192 into root 3. Okay, no mistake in calculation. So that's it, 192 root 3. So the funda here was, if you knew the formula for area of an equilateral triangle, very easily you will be able to do it. Second, if you are able to quickly identify that by joining the midpoints of an equilateral triangle, I get another equilateral triangle which is 1/4 the area of the original one. Second funda. And third, for a geometric series where the ratio is less than 1/1, the infinite sum is simply a upon 1 minus r. So three fundas they are testing, basic fundas, but if you're aware of these three things, then believe me, absolutely easy to solve this one, right? Chalo. I hope everybody understood this particular question. And yes, A is my answer in this case. Very easy question. Okay. This is again log. Love my logs. So here I'm going to remain quiet. I'm not going to say, I'm just quickly going to write the solution. And if you're not able to follow it, tell me. Otherwise, you can just take a look at the solution. Okay. It says log 81 to the base 12 is p. Then 3 times 4 minus p upon 4 plus p. Okay. So 3 times 4 minus p upon 4 plus p is 3 times 4 minus log 81 to the base 12 upon 4 plus log 81 to the base 12. Any ulta seedha base, I will split the base. So this 4 minus log 81 upon log 12 upon 4 plus log 81 upon log 12. Alright. So denominator, if I want to common, so I can write it as 4 times log 12 minus log 81 upon 4 times log 12 plus log 81. Both of them have log 12 as the denominator, gets cancelled out. This I can write as 3 into 4 times log 12 minus 4 times log 3 upon 4 times log 12 plus 4 times log 3. Why? Because 81 is 3 to the power 4. All the 4's get cancelled. So this becomes 3 times log 12 minus log 3 is log of 12 divided by 3 upon log of 12 multiplied by 3, which is 3 times log of 4 upon log of 36, which can be written as 3 into 2 times log of 2 upon 2 times log of 6. 2 and 2 gets cancelled, which can be written as log of 2 cube upon log of 6, which is log of 8 upon log of 6, which can be written as log of 8 to the base 6. Log of 8 to the base 6, option B. Absolutely easy question, but you need to be clear with your fun day in this one. Did you get this one? If you're able to follow this, give me a hands up, or else I can show it again. Can we write 4 log 312 and then simplify 4 log? I mean, you can. I mean, you are talking about taking log 81 to the base 12 and then simplifying it and getting in terms of this. You can try that. If LHS is RHS, RHS is LHS. But will it strike in what direction to go? Absolutely, you can do that. Log 81 upon log 12. So log 3 to the power 4 upon log 3 into 4. You can do that if you want to reverse engineer it. Either way, it will work. I mean, you just quickly, what steps come to your mind in the exam? See, there is no right or wrong way of doing it. Right? Ultimately, which is the fastest way which comes to your mind and where you are not prone to making errors? Because believe me, even the first time I tried, I started with this. I started with log 81 to the base 12 is log 81 upon log 12, which was 4 log 3 upon log of 4 into 3. Right? So this is 2 square. So this can be written as 2 log 2 plus log 3. So 4 log 3 upon this, blah, 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 blah. But then I got stuck at some point of time. How do I simplify this? Of course, I did LHS is equal to RHS, but I found starting from the right hand side in this particular thing is easier. You can proceed from here, but it will take too much of time. I mean, absolutely doable. I hope that helps. All right. I hope everybody followed this question. Fun question. Oh, this is one of those conceptual questions which can be easily cracked. Give it, I'll give you about 10 seconds while I have my sip of water. Think about it. How do you go about solving this? Smallest integer for which 4 raised to n is greater than 17 raised to 19. 10-second question. So the moment I take a look at the numbers which are given, 4 and 17 and 19 and all that, powers, forget it. The bases have to be comparable. So 4 and 17, 4 is definitely related to 16. So if 4 raised to n is greater than 17 raised to 19, then I can for sure say 4 raised to n will be greater than 16 raised to 19. If it is greater than 17, definitely greater than 16. So now I can say 4 raised to n is greater than 4 square raised to 19, or 4 raised to n is greater than 4 square raised to 19, 19 twos are 38. So n, if it is greater than 38, then the first integral value I get is 39, option B. That's it. So the clear-cut hint in this particular question was simply understanding that if something is greater than a number, then it is always greater than something smaller to it. So if it is greater than 17, has to be greater than 16. And 4 and 16 can be compared by making 16 the square of 4. So for equality, it may not work, but for less than or greater than, funde like. So if I get 4n is less than 17 raised to 19, or then I have to go with a higher power. I cannot go with 16. But if I say 4n is less than 15, then 4n is definitely less than 16. So if I have to come down, the inequality they will give appropriately. But ultimately, you just have to make sure that either the powers are comparable or the bases are comparable. Once you get that funda, it's a matter of point. Otherwise, 17 to the power 19 looks like 17 prime to the power prime. Nothing like that. You just have to understand that if it is greater than 17, it has to be greater than 16. One of the easiest questions that I have seen, hidden as a tough one, but definitely, once you get the funda, one of the easiest ones to crack in the paper. Less than 10-15 seconds. All right. One of the best questions I have seen in a very long time. It says, if the sum of the squares of two numbers is 97, which one of the following cannot be their product? Okay. Which one of the following cannot be their product? So it says the sum of two. So let us say a square plus b square is 97. First instinct, find out two perfect squares which add up to 97. So my squares are 1, 4, 9, 16, 25, 36, 49, 64 and 81. Obviously won't go more than 81. Squares cannot be negative. So then 81 plus 16 is 97. So I can say either A is 9 and B is 4 or vice versa. So 9 into 4, the product can be 36. But I have to identify which of the following cannot be their product. But other than this, how can there be any number? Because there is no other set of squares from these which add up to 36. Then I read the question again. It is said the sum of the square of two numbers is 97. Got the catch? It does not say integers, which means A and B could very well be fractions. Right? If A and B are fractions, I can still have the power of their squares adding up to 97, and then I can have a lot of different products. But then it says which of the following cannot be. That means out of these four, three of them are possibly the products, and one of them isn't. What do I do? Okay, so let's try to take it step by step. The first thing I saw was a square plus b square is 97. All right. So can I say a square plus b square plus 2ab is 97 plus 2ab? And this is a plus b, the whole square, is 97 plus 2ab. Now this leads us to a very interesting point. If a plus b, the whole square, is given, this cannot be negative. A perfect square cannot be negative, which means 97 plus 2ab has to be greater than or equal to 0, which means 2ab has to be greater than or equal to minus 97. So AB has to be greater than or equal to minus 48.5. But all these values are greater than 48.5. Which brings us to, let's do the other way. If I got a plus b, I can do a minus b also. So I can write a square plus b square minus 2ab is 97 minus 2ab. A minus b the whole square is 97 minus 2ab. Again, this is a perfect square. So 97 minus 2ab is greater than or equal to 0. So 97 is greater than or equal to 2ab. So AB is less than or equal to 48.5. Now I have got three values which are all less than 48.5, but I have got the value 64, which is actually greater. And I know my value of AB has to be in this range. Either it is greater than or equal to 48.5 or less than or equal to 48.5. Negative and positive, I got the range, and 64 lies outside that range. So the value in this case cannot be A. Very, very interesting question. Took me some time to understand what exactly could be done in this particular thing, but then absolutely fun to solve it. Are we following so far? I'm definitely going to have a sore throat after this. No problem, fun. All right, so let's take a look at it. Is A my answer in this case? Yes, A is the answer. Great. Now let's move on to the next one. Mod x plus 1 plus y plus 2 whole square is 0. Ax minus 3ay is 1. What is the value of A? Such a simple fundamental question. Less than 30 seconds to solve. But you need to be very, very clear on certain fundae. Let's see. Very, very nice question. It says mod x plus 1 plus y plus 2 the whole square is equal to 0. Now, two funda that we have to know. We have seen both these fundae in the past. One, a mod value is always greater than or equal to 0. X can be negative, but modulus of x will always be greater than or equal to 0. It can never be negative. Similarly, a perfect square is also greater than or equal to 0. A perfect square can never be negative. So that means the sum of two non-negative numbers, listen carefully, I'm not saying positive, I'm saying non-negative. What is the difference? Positive means 1, 2, 3, 4. Non-negative means 0 has to be included. So if I have to add two non-negative numbers and get 0, then both of them have to be equal to 0. There is no other way I can add a modulus and a square and get 0 unless both the individual entities are 0. So that means if x plus 1 is 0, I get the value of x as minus 1, and y plus 2 the whole square is 0, which means y plus 2 itself is 0, implies the value of y is minus 2. That's it. I got the value of x and y. So ax minus 3ay is 1. So a into minus 1 minus 3a into minus 2 is equal to 1. So minus a plus 6a is equal to 1, 5a is equal to 1, a is equal to 1 and 5. First option, hence proved absolute sitter question. It looked complicated, modulus plus square and this and that. Are a simple funda. If you are adding numbers which cannot be negative and you are getting the result as 0, each of the individual numbers has to be 0. Otherwise, you cannot get the value. So once you understand that, you get the values of x and y, substitute, get the answer. Brilliantly easy question. But many students would have left it thinking it is complicated. IPMAT doesn't test your knowledge of big formulae. It tests your knowledge of basic fundamentals. Modulus, non-negative. Perfect square, non-negative. Two very simple fundamentals using which you could have easily cracked it under 30 seconds. All right. So value is A, 1 by 5. Absolutely true. Log. Once again, we come to log. I think I put on too many log questions. Should I be solving this or should I just move ahead? I'll take a quick, let's see what people have to say in the chat. If you say solve, I'll go ahead. Otherwise, you can note down the question. I'll of course be showing the answer and then you can see. But it again, remember the basic 4 or 5 fundamentals of log that we saw. Nothing more than that has to be used here. So waiting to see. Do I get people wanting to solve it or me to solve it or try on their own? All right, let's take a look at how this can be done. So I'm given the value of log of x to the base something is something, log of x to the base 4 is a, log of x to the base 25 is b. We can try on our own. Jivan will obviously say that. I'm waiting for others, however. Okay. I mean, you can close your ears for some time, but for the sake of others who are not going to respond, let me show this. So one of the simple fundas that we had seen, right? So if I say log of x to the base 4, I can write it as log of x to the base 2 square, which is log of x. I can take this half outside and say this is log of x to the base 2. Similarly, log of x to the base 25 is log of x to the base 5 square, which is half of log x to the base 5. And this I can write as 1 upon 2 times log 2 to the base x. I can write this as 1 upon 2 times log 5 to the base x. That's it. So if I know this is equal to a, then I can write log 2 to the base x is equal to 1 upon 2a, and log 5 to the base x is 1 upon 2b. And now log 10 to the base x is log of 2 into 5 to the base x, which is log of 2 to the base x plus log of 5 to the base x, which is equal to 1 upon 2a plus 1 upon 2b, which is equal to 1 upon 2 into a plus b upon ab, a plus b upon 2ab. That's it. E.g. a plus b upon 2ab, third option. So wherever I see 5 and 2 and 10 in logs, I should be able to identify that 10 can be split as 2 into 5, right? And here I had to find where the base was x, and here x was the number. So obviously I had to take the inverse in this case to twist the base and otherwise. Easy problem, absolutely easy. All right, C. Again, this one is a very, very intelligent type question. It says for some non-zero real value of a, b and c, it is given modulus of c by a is 4, modulus of a by b is 1 by 3, and remember third one, plane b upon c is minus 3 by 4. And it is also given ac is greater than 0. Then I have to find the value of b plus c by a. So what all values do I have? I have got modulus of c by a is 4. I can take it as 4 upon 1. Modulus of a by b is 1 upon 3, and the simple b by c is negative 3 by 4, right? So I have got a case where I say AC is greater than 0. So this is possible that A is positive and C is also positive. So if A is positive and C is positive, then AC will be greater than 0. Another case, however, is for AC greater than 0, A can be negative and C can also be negative. Another possibility. So let's take the first one. If I say C is positive, B upon C is minus 3 by 4. So if I take C is equal to 4, and because C is 4, B will be equal to minus 3. And because B is equal to minus 3, A upon B is 1 upon 3, and A is positive, I get the value of A is equal to 1. So once I get this, I have to calculate B plus C upon A, which is minus 3 plus 4 upon 1, which is equal to 1. In the other case, where I have got both A and C are negative, if I take C is minus 4, then from this I get B has to be positive 3. And if B is positive 3 and A is negative, then A will be minus 1, because minus 1 upon this, and A is negative. So in this case, B plus C upon A is B plus C upon A, which is equal to 1. So in both the cases, the answer works out to 1. So B plus C upon A without ambiguity in this case is 1. Here, because both the cases give the same answer, solving the first one would have been enough. But good to understand is that if the product of two numbers is positive, both of the numbers could be positive. However, you also have to consider the possibility that both of them could be negative, right? So easy question, D has to be the answer in this particular case. Let's see. Yep, D is the answer here. Hope everybody got this one. Whew. Okay. All right. Haha, log. Product of the roots of the equation. Log of 2 to the base 2, 2 raised to blah, blah, blah. Oh God. Looks complicated, but actually simple. One quick observation I can make is I've got log 2x square and log 2x. I mean, this is basically the repeating. So to make life simple, let's assume for this to be the time being to be a, right? So this I get it as log 2 raised to a square to the base 2 minus 5 into a plus 6 is 0. And power I can always take outside, a square into log 2 to the base 2 minus 5a plus 6 is 0, and log of any number to the number itself is 1. So a square minus 5a plus 6 is 0. So a square minus 2a minus 3a plus 6 is 0. So a into a minus 2 minus 3 into a minus 2 is 0. So either I get a is equal to 2 or a is equal to 3. But remember, these are not the roots. This is log x to the base 2 is 2. So that means x is 2 to the power 2, which is 4. Here log x to the base 2 is 3, which means x is 2 to the power 3, which means 8. So my actual roots are 4 and 8, and product of the roots 4 8s are 32. So in this case 32 is my answer. Very, very easy question which could easily be solved. Only thing is you need to be very careful that when you see some similar term like this and you see something like this, substitute. Assume it to be a basic number so that visually it becomes clean and absolutely easy to go ahead from there. All right. So yes, 32 is my answer. Fun question, very, very easy. Reminder when 1 factorial plus 2 factorial plus 3 factorial plus blah 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 till 95 factorial is divided by 15. First of all, I hope everybody understands what is meant by a factorial, right? N factorial is defined as n into n minus 1 into n minus 2. You keep on going till you reach 1. So for example, if I say 5 factorial, this would be 5 into 4 into 3 into 2 into 1. If I say 6 factorial, 6 into 5 into 4 into 3 into 2 into 1. If I say 3 factorial, 3 into 2 into 1 and so on. So I'm adding all the factorials from 1 till 95 and I have to divide by 15. So let's see, 1 factorial plus 2 factorial plus 3 factorial plus 4 factorial plus 5 factorial and so on and so forth. The entire thing divided by 15. 15 is nothing but 3 into 5. So if a number contains 3 and 5 as its factors, it will be divisible by 15. So up to 4 factorial, the number 5 will never appear. So nothing. But 5 factorial onwards, it will always have a 5 and a 3. So all these numbers till 95 factorial will be perfectly divisible by 15. So remainder for those numbers 0. So technically I just need to see 1 factorial plus 2 factorial plus 3 factorial plus 4 factorial divided by 15 is what, and I can literally calculate. 1 factorial is 1, 2 factorial is 2, 3 factorial is 6, 4 factorial, 4 3s are 12, 2s are 24 divided by 15. 24 plus 6, 30 plus 2 plus 1 is 33 divided by 15. 15 2s are 30. My remainder is 3. Answer has to be 3 in this case. Great problem. Very, very easy to solve. You just had to be mindful of the fact that to be divisible by 15, perfectly divisible by 15, I need 3 and 5. And 5 factorial and above contain at least 1, 3 and 5 each. So all of them will leave no remainder. So it is actually only a question of the first 4 factorial summation being divided by 15. Fantastic problem, fun to solve. All right. So yes, I get 3 as my answer. Okay. Probability, I haven't seen probability coming much, but okay. The minimum number of times a fair coin must be tossed so that the probability of getting at least one head exceeds 0.8. Bad throat. Okay. This is a fun question to solve. So I need minimum number of attempts and at least one head. Okay. So the probability of any event is the number of favorable outcomes divided by the total number of possible outcomes, right? So if I toss a coin, the probability of getting a tail is also 1 by 2 and the probability of getting a head is also 1 by 2. Balanced coin, so both head and tails have equal chances. So both probabilities are 1 upon 2 and 1 upon 2. Now, if I toss 2 coins, let's see what happens. When I toss a single coin, what is the probability of at least one head? It is simple, 1 upon 2, which is equal to 0.5. But minimum, I need 0.8. So one coin is definitely not my answer. Now, when I'm tossing 2 coins, my possibilities are either I have both the heads, or first head and second tail, or first tail and second head, or first tail and second tail. And out of this, at least one head is in either both are heads or one of them is head. Or I can think of it as the total probability minus no heads. So probability of at least one head can be 1 minus probability of no heads. So in 2 coins, probability of at least one head is 1 minus no head. That is, both of them are tails. So both of them are tails. So this is equal to 1 minus 1 upon 4, 3 upon 4, 0.75. Again, not exceeding 0.8. So 2 coins will not give me. So if I toss 3 coins, then 1 minus no heads. So 3 tails, 1 upon 2, 1 upon 2, 1 upon 2. So 1 minus 1 upon 8, 1 upon 0.125. So this is 0.875. Yes. So when I'm tossing 3 coins, then the probability of at least one head becomes 0.875, which exceeds 0.8. So my answer in this case is 3. That's it. Easy. So rather than working out all the cases of at least one head, which is 1 head or 2 head or 3 head, I simply take total probability minus no heads. That will be at least one head. So that at least statement in probability is 1 minus none of it. Keep that in mind. Easy to solve. All right. So if we have got 20, we solved 20 problems so far. We are already over 1.5 hours into this. If you are interested, I can take a few more questions. If I get a thumbs up, I can take a few more questions. Otherwise, we'll call it a day. Let's see. Do I get a few thumbs up from students? If yes, we can do this. I'll wait a couple of minutes for responses. Thumbs up. Oh, great. Okay. Then let's take the next question. First of all, is 3 the answer? Yes, 3 is the answer. All right. The set of all possible values of f of x for which 81 raised to x plus 81 raised to f of x is 3 is what? Absolutely nothing to be solved, but 100% we have to rely on concepts to get this one. Let's understand what the question says. It says there is a number 81 raised to x, x is some random number, plus 81 raised to the function of that number, and I don't even know the definition of the function. Great. But I know the sum is equal to 3. All right. So what do I do this? Now, in this thing, there is one funda that we have to keep in mind, that if I have a positive number raised to anything, the answer can never be negative. A positive number raised to anything, you raise it to 1, you raise it to a positive integer, a negative integer, a 0, what, or a fraction. A positive number raised to anything can never be equal to a negative number. So again, 81 positive number, 81 raised to fx a positive number, answer positive. I can never do this unless it's positive. So for 3, I can write this as 3 raised to 4x plus 3 raised to 4 times f of x is equal to 3. Now, by some quirk, if f of x is 0, it still means 3 raised to power 0 is 1. So this has to be equal to 2, right? So for the time being, let's assume this entire value becomes 0. It won't, but let's assume it becomes 0. That means 3 raised to 4x is equal to 3 raised to 1, 4x is equal to 1, or x is equal to 1 by 4, which is 0.25. So for the minimum value, the smallest value that 3 raised to 4x can have is, let's say, 0. It cannot be non-negative. But I also know it can't be 0, which means x has to be less than 0.25. So only when 3 raised to 4x is less than something, whatever this value is will also be some positive value and I'll get 3. So the value of x has to be definitely less than 0.25. So A cannot be my answer. It won't be greater than 0.25 and 3. Again, it cannot go up till 4. It can go up till 0.25. It cannot be between 3 and 4. So logically speaking, the only possible value of x is that. Similarly, by the same logic, if x is between this, then f of x also has to be, because both of them are symmetrical. So logically speaking, the value of f of x has to lie somewhere between minus infinity and 0.25. It has to be less than 0.25. That's the only way you're going to get 3 as the answer. I hope you followed this one. So there is no calculation, not much calculation involved in this, but a very theoretical concept that, again, like we saw, modulus of something plus square of something is 0. That means they have to be 0. So again, modulus of something or square of something or power of something being added to a positive number cannot be negatives. I hope it made sense. So in this case, C has to be my answer. Very true. Okay, this is a very, very conceptual question. It asks, if the 5-digit number ABCD is divisible by 6, which of the following number is not necessarily divisible by 6? Now, what is the divisibility rule of 6? It has to be divisible by 2 and it has to be divisible by 3. For a number to be divisible by 6, it has to be divisible by 2, meaning the number has to be even. And to be divisible by 3, the sum of all the digits should be a multiple of 3. And it says that A, B, C, D, E is divisible by 6, which means E is an even number and A plus B plus C plus D plus E is some multiple of 3. So then, in all the options, A plus B plus C plus D plus E, this is definitely a multiple of 3. This is 3 times E, definitely a multiple of 3. 2 B's, 2 A's, 2 D's, 2 C's, 2 C's, definitely a multiple of 3. And again, A plus B plus C plus D, definitely a multiple of 3. So all of them divisible by 3. But E is even. So this is also divisible by 2. E is even, divisible by 2. E is even, divisible by 2. But A, I do not know whether A is even or odd. So it is not necessary A is even. And if A is not even, it is not necessarily divisible by 6. So clearly the first option, E, D, C, B, A, may or may not be divisible by 6. It all depends on what is the value of A. If A is even and if it is even, it is divisible. If it is odd, which it very well could be, the number is not divisible by 6. Clear cut. So very, very conceptual question, did ask in IPMAT, and if you know the concepts clearly, then 5-10 seconds of thinking and you get this answer. All right. This is absolutely easy. The sum of the first 15 terms in an AP is 200. Sum of the next 15 terms in the AP is 350. Then the common difference is what? So the sum of n terms of an AP is n upon 2 into 2a plus n minus 1 into d, where n is the number of terms, a is the first term, d is the common difference. So it is given sum of 15 terms is n upon 2 into 2a plus n minus 1 14d is equal to 200. The important sum of the next 15 terms, that means sum of 16 to 30 is 350. So sum of the first 30 terms minus sum of the first 15 terms is equal to 350. So sum of the first 30 terms, n upon 2 into 2a plus n minus 1 into d, minus sum of 15 terms I already know is 200, that is equal to 350. So now you have got two equations, this and this, where you have two variables a and d, two equations, two variables. You can solve it, get the value of d, you will find the answer. So I'm not going to step by step go through this. I'll show you the answer, but I definitely would encourage you to take a look at it, to solve it on your own, right? If not anything, then for the practice of solving linear equations. I hope you get that. So in this case, you will get the value of d as 2 by 3. Very easy. You just needed to know the formula, and the mistake that you will make is the sum of the next 15 term is 350. So you cannot write s of 30 is 350. It is s of 30 minus s of 15. 16 to 30 is the only thing which is 350. So s of 30 minus s of 15 is equal to 350 is what you will get. I hope that is clear. All right. Modulus. Easy. Sum of the squares of all the roots of the equation. So equation is x square plus mod x plus mod minus blah blah blah. So first, let's take x plus 4 is greater than 0, positive. So then I get x is greater than minus 4. All right. So if this is positive, then x square modulus remains plus x minus 4 minus 35 is 0. So plus 4 minus 4, I get x square plus 2x minus 35 is 0. So x square plus 7x minus 5x minus 35 is 0. So x into x plus 7 minus 5 into x plus 7 is 0. So x is 5 or x is minus 7. But I have assumed x is greater than minus 4. So minus 7 cannot be a value. So x, one possible value is 5. Now, let's assume the modulus as negative. So if x plus 4 is less than 0, then x should be less than minus 4. So now I get x square plus negative of, so this is, let's not complicate it so much. So I get x square minus x plus 4 minus x minus 4 minus 35 is 0. So x square minus x minus 4 minus x plus 4 minus 35 is 0. So minus 4 and plus 4, x square minus 2x minus 35 is 0. X square minus 7x plus 5x minus 35 is 0. So x into x minus 7 plus 5 into x minus 7 is 0. So x is either minus 5 or plus 7, but it is less than minus 4. So again, possible value is this. So my two roots are 5 and minus 5. I need to find the sum of the squares. So 25 plus 25, I get my answer as 50. Sum of the two squares. So remember, although you get two values, 5 and minus 7, the condition is important. In the first case, only the value greater than minus 4 will work. And in the second one, only the value less than -4 will work. So although 4 roots, 2 of them are impossible roots. So that means only 2 possible roots here. You just need to be mindful of this fact. All right. And then let's take one last question then, 25th. The sum of up to 10 terms of the series. Now this is a classic type of question, but here what mistake you will make is it is not 1.3, 5.7, 9.11. No. The notation is 1 into 3 plus 5 into 7 plus 9 into 11 up to 10 terms. So now remember, whenever we had something like this, we had to identify what were the two series. So the first series is 1, 5, 9 and so on. So A, the nth term is given by A plus n minus 1 into D, 1 plus n minus 1 into common difference 4. So 1 plus 4n minus 4, so 4n minus 3. My second series is 3, 7, 11 and so on. So the nth term is A plus n minus 1 into D, 3 plus 4n minus 4, so 4n minus 1. So any term in this series is actually 4n minus 3 into 4n minus 1, which can be expanded as 16n square minus 16n plus 3. So now I have to find the sum of n is equal to 1 to 10 for 16n square minus 16n plus 3. Now remember, there are a few formulas which will come in handy. These are called the summation formulas. Summation of a constant is n for n1. Summation of n is n into n plus 1 divided by 2. Summation of n means 1 plus 2 plus 3 up to n. Summation of perfect squares is n into n plus 1 into 2n plus 1 divided by 6. And summation of perfect cubes is n square into n plus 1 the whole square upon 4. So for this, I can write it as, take the constant outside, minus 16 sigma n plus 3 into sigma 1. So summation n square is 16 into n plus 1 into 2n plus 1 divided by 6 minus 16 into n plus 1 divided by 2 plus 3 into n, and I need 10 terms, so value of n is 10. So 16 into 10 into 11 into 21 divided by 6 minus 16 into 10 into 11 divided by 2 plus 3 into 10, 30. That's it. Simplify it and you will get the answer. Absolute easy method of here the funda is using the funda of AP. I find the formula for the nth term. So I can write it, I can write each term as this, and then the summation formulae I can split, and after that it's simply matter of plugging in the values, because I have to find 10 terms. Plug in the values, and in this case the answer is 5310. I hope these questions were useful. So things like modulus, things like squares, things like possible positive or negative values, things like summation, logarithm. These are the basic concepts which are asked many times. Now some students are afraid of questions which come from determinants, matrices, trigonometry and all that. But seriously, the cutoffs in both the math sections, whether it is short answer or MCQs, is never too high, right? So out of 10 questions, I can say if you are able to safely solve 5 or 6 out of, not even 15 questions, out of 15 questions of short answers, even if you solve 6 or 7 of them, and in maths MCQs, if you are able to solve out of 30 questions, let us say about 9 or 10, 1/3 of the questions also if you solve, and of course a little more in case you get some wrong, the cutoffs can be cleared. So the problem is not math, it's the verbal abilities section which has a high cutoff. But even in that case, you have got 45 questions and out of that, if you are able to get at least, let's say, 32, 33 of them correct, or 35 plus with a few wrong ones, you can still make it. I mean, I'm talking about cutoffs for IIM Indore. So, like I said, you have to control your negatives. You have to be very mindful of what exactly is the data in the question, and then go ahead from there. Right? So, I'll hang on for a couple of minutes. If there are any questions, I am ready to answer them. Otherwise, it's been a pleasure taking this session. I keep posting these online videos before exams. So, if there are, you can always follow me on the YouTube channel. IQ Digital is the YouTube channel, and get in touch with me in case there are any queries, if there are any doubts. Otherwise, wish you all the best. Please make sure that you have taken a print of your admit card for the IPMAT Indore exam. Read all the instructions carefully. I think you have to paste your photograph or something on it. If that is the case, make sure it's the same photo as you uploaded at the time of application. Read all the instructions. Read the exam center well before time, right? Don't make it to the last moment. Be very careful. At whatever test center you have, you may not have the facility to keep your belongings. They may or may, the test centers may or may not have safety lockers, and you are not allowed to carry anything except your ID card and maybe your exam hall ticket. So in case you are carrying anything else, you might have to leave it outside with somebody. So please take appropriate measures for that. In the exam, don't panic. Like I said, you barely have to solve about 1/3 of the questions in both math sections. So it's all a question of how wisely you select the questions to be left out. Right? You can easily leave out about 2/3 of the questions and still clear the cutoff. So don't panic if you're not getting a lot of questions. And believe me, there are at least there are at least 2 or 3 questions more than the ones required for cutoff, which are sitters in every edition of the exam. The reason why most students are not able to do it is simply because they panic. Stop panicking, and I'm sure you will be able to solve many, many questions. So here's wishing you all the very best. If there are any questions, you can put up in the YouTube comments. Otherwise, please do hit the like button, subscribe to this channel, and wish you all the very best for this exam.